So what is that dual nature? And I'll say that even matter also quantized, velocity, momentum, everything is quantized. That's also I propose. So I think in chemistry atomic structure, you might have come across a little bit idea that quantization. Here I'll try to introduce the idea of quantization, because again, when we go to atomic structure, I'll bring the quantization word, the quantization. So that quantization, let me introduce here only. So let me first take this one. So as we know, de Broglie wavelength of de Broglie matter waves depends upon h by mv. What is value of h? 6.62. Let's do for a person. Let the mass of person be 75 kg. And it's running with a speed how much? 8 kilometer per hour. So this will become how much? 2.2 meter per second. And mass of the person how much? 75 kg. No substitute here. So if I calculate this, roughly I'll end up with 4.016 into 10 to the power of minus 36 meter. Why we are unable to see when the person, in fact, what that person, the person of mass m is running with a speed v. Why we are unable to notice that particular matter waves associated with that person? So where is that lambda? Can you show that wave? Can you show that wave? So what is this matter waves? So how to interpret this matter waves? I said that there's a wavelength of the matter waves associated with the person. Where are those waves, sir? How you show that one? See that it is what do they carry? These matter waves, what happen? There's a matter wave associated with a person, or wavelength of, let me write here, wavelength of associated with person running. So when he runs, what happens? This much of wavelength is associated. So this particular, these waves happen, these matter waves, will they carry any charge? Will they carry any mass? No. The matter waves, the matter waves will not, themselves will not carry will not carry okay, the matter wave themselves carry on this one no mass, or that one no charge, no momentum, no energy, this one no angular momentum. This is very important discussion. I think maybe in chemistry, I don't know how you studied, but in physics, what happened, I should give a clarity that one. No information, no information of any sort other than the likelihood of existence. So in general, what do they carry? They just carry information. So what do they carry? Just they will specify that at a given time, like they'll specify place and the specific time. So here matter waves are existing here. So where at this particular point, and the peak there will be maximum. Yesterday I just shown that there you have to, if the person is there, no. So for your understanding purpose, I'll just put it. So you have to put like this here. So what do this matter waves? It's a probability waiver, just for your understanding that one. So what do this particular matter wave will tell us is like a, just it will specify in that given environment the specific place and the specific time. The matter waves what happen will interact with environment at specific place and specific time. Then when the person reaches there, when the person here, what happens? This matter wave also will shift. Means can it propagate as matter waves will propagate? Already we have discussed that one. Again, the group velocity, phase velocity, all will come. So let's not bother. Just having a general idea that one. This is a probability. So what matter waves will just give us? It will give just some sort of information. What is that? It will give us the location of the particle. It means in a given environment, it will give the location of particle at a given time. That's finish all. Afterwards, nothing to do with all this one. I think you'll feel happy because angular momentum conserved, no need of conservation of angular momentum, no need of energy conservation, no need of momentum. Charge is conserved, nothing to do. What about mass? Nothing. Just it will give us information that at a that particular like a particle is existing at a given place at a given time. Where the probability function is having peak, no, they definitely can say the particle is nearby it. And as you move away, what when the probability of the particle finding out will decrease. That's what we say like this. So the matter waves will be distributed from the position of particle to till infinity. And where the probability of particle is more, there the peak will be more. This was the thing that one. I think this will be really, you should just imagine how de Broglie assumed all these things. How de Broglie assumed all these things. And further he said that this is like a, means why do we don't feel? Okay, this is about one information. Why we don't feel this matter wave? Why we are unable to see? Look at this wavelength. Also due to running person, 10 to the power of minus 36 meter. To detect this particular wavelength, what happen? We need diffraction slits where the width of the slit should be of order less proportional to this one. Can we construct? I don't think so. What is the nuclear range? What is the atomic molecular range? 10 to the power of minus 10 meter. No, finish over. Or put the most or put at the most what will happen 10 to the power of minus 16. Beyond that, what happen? The modern science and technology cannot measure the separation between 2 points more than 10 to the power of minus 10 or 10 to the power of minus 16. You can put it maximum. So no way what happen? Like we cannot even select a this matter waves because we don't have such particular experimental setup. Maybe in future.
బెడ్రూమ్ అదే బాత్రూమ్ లో కడుక్కో.
Hello, please mute. No, why to unmute and do something? Huh? Chaturya. How to detect matter waves? We can't detect. We can't detect matter waves. So don't use word detect here. Only it was proposed, but it will do exist is what experimentally what will happen. I'll show that one. I'll show one. That's what the Davison German experiment. That's what the Davison German experiment means. That one. Okay, got this. So I'm making some things very clear. So what is the biggest problem? Is like, of course, when you say wave, no. So any diffraction pattern, any interference pattern, then we need the spacing between the two lines should be of this much here. Then if you pass that matter waves as diffraction will occur, then we can notice. But I can't produce any physical quantity where the separation between two lines or 2 points which will be of this order. So totally ruled out here. Maybe we have to wait with the time as our technology grows. Future maybe. Okay, got this. So there's a general idea. So why we don't feel that one. Next again, what de Broglie proposed is even the matter. The main purpose of the de Broglie matter waves is matter is quantized. So the next statement is what?